You are welcome to Asanje Academy for Global Conquest. This is an e-platform for learning, and we have a lot of content. We have lots of content for you. So if you go through this and it interests you, I would like you to click the notification button as well as subscribe so that you will receive content each time is uploaded onto this platform. We are looking at advanced level physics, and it is options we are treating this series. We'll be looking at option one, which is energy resources and environmental physics. We'll be treating 2020, 2021, as well as 2022. We'll be treating 2020, 2021, and 2022. We are going straight into the subject matter, and that is June 2022. We'll be looking at question number 8. Question number 8A. It says the following diagram shows the energy flow diagram sequence in the main component of a hydropower plant. This is the question. It has this gravitational potential energy. You have to fill this box, fill this one with forms of energy, and you also have to fill these because we are asked to copy and complete this diagram. You have to copy this diagram and then you complete it. What do we have as the answer? This is the answer. This is the gravitational potential energy of the water in the reservoir is converted to kinetic energy of water as it runs down the penstock. Then when it enters the turbine, it is converted to rotational kinetic energy of the turbine and the rotor. Then we finally have the electrical energy of the generator. So we have two forms of energy: kinetic energy of the water in the penstock and rotational kinetic energy of the water in the turbine, rotational kinetic energy of the turbine and the rotor, which will now give us electrical energy of the generator. Question number 8A Roman 2. 8A Roman 2. It says in one hydroelectric power plant, the height of the reservoir above the tail raised is 56 meters. The average water discharge at the spiral casing every second is 150 centimeters cubed. Determine the power output from the turbine if its efficiency is 72%. Generally, we know that efficiency is equal to power output on power input, all of that multiplied by 100%. Now, what do we have? We have that energy on time is equal to power. But what kind of energy? Potential energy, MGH, on time is equal to power. Why? Because we are asked to calculate power output. So we have been given the efficiency, so we need to work out the power input from the question. We have all that is needed. All the parameters have been given for us to be able to work out the power input. We have MGH on time is going to give us the power input. But also we have it that the mass of the body is equal to the density and volume. So density and volume are sitting in for mass. Again, the equation is rearranged like this: volume on time. Why do we rearrange it as volume on time? Because we have been told that the average water discharge at the spiral casing every second is 150 centimeters cubed. So this is 150 centimeters cubed per second, which is the volume on time. So it's good to know that. Then This is our conversion. This conversion is very important. The volume on time is 150 centimeters cube per second. But remember, we must convert it to meters per second because our working unit for volume is meters cube, is not centimeters. So to convert 150 centimeters cube per second, we will have it as 150 times 10 to the power minus 6 meters cube per second. We have 150 centimeters cube per second is equal to 150 times 10 to the power minus 6 meters cube per second. Now, if we rearrange this equation so that we have power output, because in the place of power input, we have already substituted V on T, all of it multiplied by rho GH. V on T, volume on time multiplied by rho GH has been substituted in the place of power input. So if we work out the power output, we're going to have the efficiency times density times the rate of volume flow with time times gravity and height. If that is well substituted, 72% is equal to 0.72 times 1000, which is the density of water, times the volume rate of flow with time is 150 times 10 to the power 6 meters cube per second, times gravity, which is 9.8, multiplied by the height, which is 56. If we compute that, if we using our calculator, if we compute that well, we're going to have our power output as 59.3 watts. 59.3 watts. We will look at question number 8A, Roman 3. It says distinguish between fossil fuel and biogas. Fossil fuel and biogas. The first distinction is that these ones are very clear. I want just to list them out. The first distinction is that fossil fuel are non-renewable while biogas are renewable. Fossil fuels take long to be formed while biogas are formed recently are from recently living organisms. Fossil fuel has toxic byproducts and ingredients, while biogas is non-toxic. Question 8B, Roman 1. It says large-scale industrial products could be achieved through fusion of small nuclei in which energy is released. That is true. State one advantage nuclear fusion has over nuclear fission as a means of large-scale energy production. Fusion is the assembling lighter nuclides to produce heavier ones, while fission is the splitting of heavier nuclides into fragments, into lighter ones. So why is it that fusion has, what are some of the advantages of fusion over fission? There are a good number of them. We have the first one is that the end product of nuclear fusion are not radioactive. Therefore, they do not pollute the environment like fission. An example of a fusion reaction is when hydrogen comes together to form helium. But an example of fusion is when uh, uh, uranium reacts or is bombarded with neutrons to produce a krypton and barium. So fusion, the end result pollutes the environment, but for fusion, the end result is what? We have water. The end result is not radioactive, does not pollute the environment as it's not radioactive. What is another difference? The energy release per mass of fuel for fusion is greater than the energy release for fission. It means fusion generates greater energy than fission. The last advantage of fusion over fission is that the fuel that is needed for it is from water. It is cheaper and is abundant. Deuterium is hydrogen too. We can get it directly. deuterium can be gotten directly from water, but the fuel that is needed for fission is from uranium, and it's expensive to treat to enrich it before we can start producing energy from fusion. So we see that the source of fusion is readily available, but the source of fission is more expensive and scarce to find. Question number 8b, Romans 2. We have an equation which we are asked to compute. We have an equation which we are asked to compute. And this is the equation that is loaded. It says the following equation shows a typical fusion reaction. We have hydrogen 2 plus hydrogen 3. Hydrogen 2 is called deuterium and hydrogen 3 is called tritium. It reacts, this is fusion, fuse together to form helium plus neutron and energy. So calculate the average energy delta E that is released. We have the mass of hydrogen 2 is given, the mass of hydrogen 3 is given, the mass of helium is given, and the mass of the neutron is given. So how do we go about doing this calculation? We know that from this equation delta E is equal to delta M times 931 mega electron volt. This is a general equation that we know. I'm sure we are all familiar with this equation. Then what else do we have? We have that this delta M is the mass of the reactant minus the mass of the product. The mass of the reactant minus the mass of the product. These are the reactants and these are the product. Their various masses have been given in this table below. So if we do our arithmetic correctly, this is the mass of hydrogen 2 plus the mass of hydrogen 3. This is the mass of helium plus the mass of uh, uh, the neutron. So if we do this arithmetic well, we're going to have 0.01219 units. Therefore, the change in energy is this mass defect times 931. This is from mega electron volt. This is delta M times 933 times mega electron volt. If we compute this, we're going to have 2.03 times 10 to the power minus 12 joules. Roman question 8b, Roman 3. It says given that the mass of 1 mole of deuterium is 2.0 grams, how much energy is released per kilogram of deuterium? It's a very good question. What have we been told? What have we been told? We have been told that 2.0 times 10 to the power minus 3 kg. Why 2.0 times 10 to the power minus 3 kg? We are converting these grams to kilograms. It has the Avogadro number of 6.02 times 10 to the power 23 23 particles. 23 particles per mole, has 23 particles per mole. Therefore, 1 kilogram will have 1 kilogram times 2.3 times, this is 10 to the power 23. 10 to the power 23 divided by 2.0 times 10 to the power minus 3 gives us 3.01 times 10 to the power 23 particles per mole. Hence, the energy released per kilogram is what we have calculated per mole times 2.83 times 10 to the power minus 12. This was the energy we calculated from the reaction behind. And the final answer is 8.5 2 times 10 to the power 14 joules. We will be looking at C Roman 1. Question C Roman 1. It says explain the meaning of greenhouse effect. Explain the meaning of greenhouse effect. It is a process by which radiant energy from the surface of the earth is trapped by greenhouse gases and re-radiated back to the earth in every direction. Now we have a kind of a diagram that shows the rays from the sun, they enter the earth. This area, they enter the earth through this area. This area contains green, uh, the greenhouse gases like carbon dioxide. These are the greenhouse gases. This area, this ring around the earth, around the stratosphere of the earth. When the short wavelength penetrate, they pass through this area and they heat up the earth. They heat up the earth now radiate energy to radiant energy, releases radiant energy. As the radiant energy goes up, it is trapped by these greenhouse gases and so is re-radiated back onto the earth, and that is the meaning of greenhouse effect. Greenhouse effect, that's the meaning of greenhouse effect. It is a process whereby radiant energy from the surface of the earth is trapped by these greenhouse gases. Carbon dioxide and other gases form the greenhouse gases. They are trapped so that they can't escape, and they are re-radiated back to the earth in every direction. We look at C2. C2, describe a method that can be used to produce one of the consequences of greenhouse effect. Describe a method that can be used to reduce one of the consequences of the greenhouse effect. What are those methods? Uh, we use environmental friendly sources of energy. Two, we plant more trees to stop deforestation. 4, we reduce our dependence on fossil fuel. And 5, we reduce the production of chlorofluorocarbons, and we also do mass education. People need to be educated on what these greenhouse effects are. We are told to use environmental friendly sources of energy. Why? This carbon dioxide is a threat as it forms a ring around the earth. It does not allow radiant energy to go out. It rather re-radiates radiant energy to the earth. And what happens? It increases environmental temperature. So what should we do to reduce the effect of this greenhouse effect? What should we do? We should use environmentally friendly sources of energy like water, like wind, like tidal variation, and so on. We should also plant more trees. Why should we plant more trees? So that the trees will absorb carbon dioxide in the atmosphere. Why should we stop deforestation? As we cut down trees, we are exposing our environment to much carbon dioxide. We should reduce our dependence on fossil fuel because fossil fuel, they release a lot of greenhouse gases. We should also reduce our dependence on these chlorofluorocarbons. These chlorofluorocarbons, they do a lot of depletion of the ozone layer, which will rather increase the amount of energy entering into the surface of the earth and also will raise up the temperature of the earth. We should also do what? We should educate. There should be mass education because we are told that little drops of water make an ocean. We go to rural areas, people keep burning rubbish. They don't know how to recycle everything they have. They burn around the rubbish, they burn around the neighborhood, and they are stirring up, they are increasing the quantity of carbon dioxide in the atmosphere. So there is need for mass education.